Hi students, welcome to EC Engineering. So today we are going to discuss about Unit 2 Combinational Circuits. So I'll be giving the basic introduction about the combinational circuits and sequential circuits. So a digital system consists of both types of circuits, which are your combinational circuits and sequential circuits. Before going to the digital system circuits, you have to know the difference between the combinational circuits and sequential circuits. So what are combinational circuits? So your combinational circuits consists of basic logic gates whose output at any time is determined from the present combination of inputs. That is, your combinational circuit at any point of time is dependent only on the present state. Okay, well. Next one, the combinational logic gate is the most basic building block for your combinational logic circuits. Next, what is your sequential circuits? So this is also comprises of your logic gates, but there is a difference between the combinational circuit. That is, the output of the sequential circuit, it depends not only on the present value of the inputs, but also on the past state of the inputs. So a combinational circuit, it depends upon the present combination of inputs, whereas your sequential circuit, it depends both on the present value of the input and also on the past state of the inputs. So there is a need for a feedback system in your sequential logic circuits. So why there should be a need for a feedback system? In order to store the state. In order to store the state, we need a storage element and also provide a feedback for the past input. Okay, so your sequential logic circuit, it consists of feedback element which acts as a storage component. Whereas in your combinational circuit, there is no need for an feedback element. Okay, since whatever the input I'm going to give, it is going to produce my output. Okay, but for my sequential, it depends both on the past state as well as my present state. I'm in a need for my storage element, okay, and also a feedback element. Most of the cases, my storage element is going to be my flip-flops and latches. So a flip-flop or a latch will be acting as a storage element in my sequential logic circuit, which is capable of storing a 1-bit data. So the data can be either 0 or 1. So these are the basic difference you have to know between your combinational circuits and sequential circuits. There are many examples. So this is the basic block diagram representation for your combinational logic circuits, where I am going to give n input variables as an input to my combinational logic circuit, and I am going to produce my m output variables for the n input variables. Okay, so this is the thing you have to know about the block diagram representation for your combinational logic circuit. Next thing is that there are many examples for your combinational logic circuits. So hereafter we are going to see many examples like your adder circuits, your subtractor circuits, your multiplexers, your demultiplexers, your encoders, decoders, your code converters. Everything falls under this category. Okay, so these are some examples of your combinational logic circuit. So now in today's class, we have discussed about your combinational circuits and sequential circuit and the examples for your combinational logic circuits. In the upcoming classes, we will discuss in detail about the examples and also the design procedures. So keep watching. Kindly subscribe my channel EC Engineering and click on the notification button for the upcoming videos. So thank you everyone.